Ever wondered how machines learn and make decisions? It's not magic, it's machine learning. Picture this. Just as we humans learn from our experiences, machines too learn from patterns and data. They draw from vast reserves of information, identifying patterns and making informed decisions based on these patterns. It's like teaching a child to recognize a dog by showing them lots of pictures of dogs. Over time, the child understands the concept of a dog, even if they come across a breed they've never seen before. That's because they've learned to recognize patterns. In a similar fashion, machines learn. But instead of a human brain, this learning process is powered by something called neural networks. These networks are the beating heart of machine learning, the secret sauce that gives machines their ability to learn. So, what are these neural networks? Let's dive in. Neural networks are the brains behind machine learning. They are inspired by our own human brain and its billions of interconnected neurons. Just as our brain takes in sensory information, processes it, and makes decisions, neural networks do something similar. They take in inputs, process them through what we call hidden layers, using a system of weights that are adjusted during training, and then output a prediction. Think of it like this. You see a red traffic light. Your eyes take in the color, your brain processes it and recognizes it as a signal to stop. In a similar fashion, a neural network would take in the input red light, process it through its hidden layers, adjust the weights, and output the prediction stop. But it's not magic, it's mathematics and a whole lot of data. But how do these neural networks learn? This is where deep learning frameworks come into play. Deep learning frameworks are the tools that make machine learning possible. They're like the training grounds for these neural networks. Imagine them like virtual gyms, where our neural networks, or brain athletes if you will, go to bulk up their predictive power. Now let's talk about some of the popular frameworks. First on the list is TensorFlow, developed by Google. It's a favorite among many due to its flexibility and extensive community support. TensorFlow allows neural networks to learn from data and improve their predictive capabilities. Next up is PyTorch, a product of Facebook's artificial intelligence research group. PyTorch is known for its simplicity and ease of use, making it a popular choice for beginners and experts alike. It also allows neural networks to train and enhance their decision-making skills. These frameworks provide the environment for training neural networks, refining their abilities to make predictions or decisions. Now that we understand how these networks are trained, let's explore some of the most common architectures. Just like buildings have different designs and structures, neural networks also have various architectures, each with its own strengths and uses. Now, let's dive into some of the most common ones. Convolutional neural networks, or CNNs, are the go-to for image processing. They're like having a set of digital eyes, scanning an image and recognizing patterns pixel by pixel. They're the magic behind facial recognition and self-driving cars. On the other hand, we have recurrent neural networks, or RNNs. These are incredible at handling sequential data, such as text or speech. You can think of them as having a memory, each node remembering a bit of information from the previous one. They're the reason your voice assistant understands your commands and can even predict what you're about to say next. These architectures are designed to best handle specific types of data, and they're constantly evolving to become more efficient and accurate. So next time you use a voice assistant or a recommendation system, remember the sophisticated networks and architectures working behind the scenes. In a nutshell, machines learn by recognizing patterns and making predictions through neural networks. We've traversed the terrain of neural networks, deep learning frameworks like TensorFlow and PyTorch, and various architectures including CNNs and RNNs. With this knowledge, you're one step closer to understanding the fascinating world of machine learning.